Okay, hello everyone. In this video, I will show you how to doing the lab 1. In this lab 1, we will know how to use the Vitis HLS tools and how to design the device. In this lab, we will design the device that have ability to compute the metric multiplication, such as we have a device with input A1, A2, and A3, and the second input is B, which has the input B1, B2, and B3. The device will be multiplied because we want to design it, multiplied both of them between A and B, and the result will be stored or will be saved into R. This is the general flow. The first one, we will create a project using the Vitis HLS. The second one, we will create the device design using the C, and then we running the C simulation, synthesize, analyzing, and performing the code simulation, and the final is we will get the RTL as an IP. The first thing that you need to do is open the Vitis. It's right here, Vitis HLS. Okay, this is the first view when we are opening the Vitis HLS. We can create the project, open the project. Before we create the project, we need to make the folder. Where is your workspace folder? I choose the folder will be in the document. So I need to create the folder name lab1, lab1. And then we create the project. The name is metric multiplication or metmul. This is the project, and the location will be in the folder that we have been made before. In the document, choose lab 1, select folder, and then next. We need to make the top function, which means this is the main function of this project. The name must be the same as the project name. So the top function will be metmul, and then next. We just next. And then we must choose the device that we will be implemented. We can select the board using in this part. So just click in this part and you choose the board, and we will implement into the Zinc 7 ZC702 board, and then just press OK, and the period or the clock just as the default will be 10, and just click finish. Here is the console that we will work. There is 4 folder. The first one is include, which means you can write the C header in here. The second one is source. You can write the C source code in here. And the third one is test bench, which you can write your C code or another code that used to test the source. And the last one is the solution. After we synthesize and performing the analyze, and the last one is exporting the RTL. So the solution will be in this folder. The first one, we will make the C code in here. Just right click, and then new file. and the name will be metmul.cpp, and then save. In this part, you will write your C code to make what is the logic, what is the algorithm that will be converted into VHDL. For example, we will make uh, the metric multiplication algorithm to synthesize it. So you must write this code, source code. The first one is include metric multiplication.h, which means we will load the header file, the C header file. And the second is we will write the metric multiplication function in here. The input will be 2, A and B, and the result will be in R in here. So you need to write the C code in here. The first one we write include metmul.h. You need to write all of this. After we write the C code in here, so we have been write the function called metmul or metric multiplication, which contain the A. The A is input. The A variable will be corresponding to the met_A class, and the B is met_P class, and the R will be the met_R class. And the algorithm will be multiply each column of the A and B column, and then A and B row. This multiplication using a scalar, just like illustrating in here. Each column will be multiplied by each row of the B matrix. So B1 will be multiplied by A1, and plus by B2 multiplied by A2, and then plus by the B3 multiplied by A2. After you write, you need to save this C code, and then save. After you write the C code, you need to make a new file, which is the header C header file in here, metmul.h, and then save. The metmul.h will be contain the C header file, that the content of the A variable and B variable defined in here. And then we need to make this C header file. So we write this C header file in here. After we have finished type this header file, you just save this header file. Okay, save. Okay. And the last one, which is the test bench. The test bench will be test our source code. So the test bench will be testing this algorithm correct or not. In the test bench, we need to add new file, I will give you next the file in the link below, so you can download the testband file in the link below. After you are downloading the testband file in here in download, you need to copy this file into the workspace folder, into lab 1 folder, and inside of lab 1 folder. So just paste in here, and after you paste in that folder, you just right click and add new file. Choose matmul test.cpp. So after this, you should check one by one. The test bench is matmul underscore test, and the source will be matmul.cpp, that this file we create before, and in include you just check in lab 1 folder, which is our workspace folder here, matmul.h. So all file have been inserted in this project. I will explain to you what is the code or source code inside the matmul test. In the matmul test, we define two input of metric. The first one is input metric A, which is the metric which has two rows and 3 columns, which is the value of this metric is 1, 2, 3, 4, 5, and 6. The second one is B matrix, input metric B, which is the metric which has size 3 by 2, and this metric have the value in each column on row is 1, 2, 4, 5, 7, and 8. After that, the result will be saved into folder into two variable. The first one is HW result, which is the 2 by 2 matrix. Why 2 by 2? Because when we are multiply 2 by 3 matrix with 3 by 2 matrix, the result will be 2 by 2. Just eliminate between the column of A matrix and row of B matrix. So after that, this is test in the software. So they count the multiplication in this function, and the result will be saved in HW result. After that, we will check our design in here, CPP, by call back this function called matmul multiplication. So it will be call this function into the test band, and then the result will be saved in HW result, and then they will be checked how is the result between HW result and SW result. It's same or not. If it's not same, they will be count the error in here and save how many error in here. And then if there is no error or there is no mismatch, so there will be print out test has been passed. If there is an error, they will be show how many the error in here and show mismatch is detected. Okay, so this is for testing this function with their own function in here. This is for testing the function in the source. After this, you need to run using run C simulation, and then just click OK. You can see in here in console. Okay, after you're clicking the run with C simulation, the C simulation will be start in here, and they will be compiling this matmul test.cpp, and they will be check the matmul.cpp in here, and then this is the result of the multiplication. You can read this C simulation in here. You also can read in here the report, solution, csim and report, and matmul csim log. They will be show you the test has been passed, and this is the result. You can check if 1 2 3 4 5 6 multiplied by 1 4 7 2 5 8. You can check the result, it will be correct or not. And then after the simulation is passed in here, the C simulation passed in here, you can run the solution and run C synthesize, and then you can run the C synthesize in here. Just click, left click, and they will be synthesize our design in here, matmul.cpp. Okay, and then they will be implemented our source C source code, and this is the result of our design. This is the module that we made, or the device that we will be made into the VHDL or Verilog. The result is we have a 7 in the iteration latency, and the total will be 14 cycle, and this is the interval, and the memory this is for the memory, and this is the level top level control. You just concern in the interval and the latency. You can see in here how many how fast is your design, or how about the performance of your design in here. And then after you run the C synthesize in here, you can check the synthesize using the code simulation in here, and then you will be send the simulation using a Verilog or VHDL in here. You can run both of them. The first one, I will show you the simulation using the Verilog. Just press OK in here. Okay. Okay. After simulating the C simulation in here, they will be implementing our device. Just press allow access. And then our code simulation in here, which is check our design after C simulation. The status will be passed in here. So we have successfully designed the metric multiplication in here. And this is the maximum latency and the minimum latency and the average of the latency in here. You just check this is pass or not. And then after you run C code simulation, you will check the logic in here. You can check. This is the latency, and have a 7 iteration in here, and the trip or the loop have been counted in here 4 times of loop. And you can check in the logic in here. The design will be automatically have made the pipeline in here. This is the pipeline process. So they will be automatically made the process in here. This is the loop where they process the loop. They make the device one by one, and after we synthesize the C simulation, and you can check, such as in this process, at LN5, you can right click and go to the source. This is the process in here. They synthesize this C source using add underscore LN5 module. And another one such as ZX LN9. This is the process that synthesizes it from this source part. And the final one, you can export this solution into VHDL. This one. You need to check and click this one, Vivado synthesis, place and root. They will be automatically place and root the device. If you want to make the file configuration, you will write in here when you have a company such as our lab, the STL company. You can write in here what is your name, what is the device name right here, and you can write the description of the device, and then just press OK and OK. They will be exporting the solution. You need to waiting the exporting, and they will be checking our design automatically. Okay, after finish exporting the RTL or IP, you will get this report. You just check the timing of our device will be met. You just check this. If this report is not show, maybe our design is wrong. So you need to check the timing is met or not. So this is our result. The timing is met. So the exporting of the IP or RTL is finished. You can check this in the implementation folder, EMPL implementation folder, and in the report Verilog, because we run the synthesis in the Verilog here, the report, and you can check the IP and in the HDL Verilog. This is our Verilog and this is the code for Verilog, how to make the device with can multiply the matrix. So this is the end of the lab 1. See you in the next video.